Hello friends, today we shall discuss exercise 3.5 question number 1. Which of the following statements are true? If a number is divisible by 3, it must be divisible by 9. Let us take one example. Suppose if a number is divisible by 3, it must be divisible by 9. Suppose the number is 21. 21. If I take one example, that is, if I have taken the number 21. Now you see, if we divide 21 by 3, we are getting 3 7 21. Then it is divisible by 3, right? 3 7 21. 21 is divisible by 3. But if we take 21, is 21 divisible by 9? Divisible by 9? No, we are not getting a whole number. It is not divisible, right? Therefore, if a number is divisible by 3, it must be divisible by 9 is not correct. That is, it is false. Again, we are explaining, if a number is divisible by 3, it must be divisible by 9. If we take the number 21, it is divisible by 3. That is 3 7 21. But if we divide it by 9, it doesn't divisible. It is not divisible, or it has remainder, right? Or we cannot get any whole number. Therefore, it is false. Number 2, B. If a number is divisible by 9, it must be divisible by 3. We know a rule that if a number is divisible, suppose one number, suppose 18. 18 is divisible by 9. Any number, take any number, suppose 18. Now 18 is divisible by 9. 9 to 18. That if a number is divisible by a particular number, that number, this number will be divisible by the factors of this number, right? That is, the factors of 9 are 3. 3 3 is 9. 3 is a factor of 9. Therefore, 18 is also divisible by 3. 18 is also divisible by 3. 8 3 6 is 18, right? That means if a number is divisible by 9, it must be divisible by 3 also. This is true, right? This is true. Right? Now see, if a number is divisible by 18, if it is divisible by both 3 and 6. If a number is divisible by 18, if it is divisible by both 3 and 6. Let us take one number, that is 3. Suppose we have taken 18. Now you see, 18 is divisible by 3. 3 6 18, right? And 18 is also divisible by 6. 18 is also divisible by 6. That is 3. Now, a number is divisible by 18 if it is divisible by both 3 and 6. Now we see that this number is divisible by both 3 and 6. Therefore, 18 is also divisible by 18. Divisible by 18. That is 1. That means a number is divisible by 18 if it is divisible by both 3 and 6 is true. This is true. This is true. Right? Next, D. If a number is divisible by 9 and 10 both, then it must be divisible by 90. If a number is divisible by 9 and 10 both, then it must be divisible by 9. Let us take one example. Suppose the number is 900. Take one number 900. Now you see, 900 is divisible by 9. Divisible by 9, that is 100. And 900 is divisible by 10 also. 900 is divisible by 10, that is 90, right? Then it must be divisible by 90 also. And you see here that 900 is also divisible by 90, right? Then we are getting 10, right? That means this is true. Right? Next one, if two numbers are co-prime, at least one of them must be prime. This is not a necessary factor, right? Suppose we are taking two numbers, one is 18, one is 18. Suppose we are taking two factors, one is 18, one is 18 and 35. Now, if you find that factors of 18 are 1 into 18 is equal to 18, 2 into 9, 18 is equal to 18, 3 into 6 is equal to 18, right? 4, 5, 6, no, right. Now factors of 35, that is 1 into 35 is equal to 35 and 3 and 5 into 7, 5 into 7 is equal to 35. Now you see here the common factor is only 1. That means these two numbers are co-prime, but here the 18 and 35 are not prime number. At least one of them must be prime. That is not true, right? Here you see both the primes, both the numbers are not prime number. 18 is also not prime and 35 is also not prime. That is, if two numbers are co-prime, at least one of them must be prime. That is false, right? Now question number F. All numbers which are divisible by 4 must also be divisible by 8. All numbers which are divisible by 4 must also be divisible by 8. Let us take one example, right? All numbers which are divisible by 8 must also be all numbers which are divisible by 4 must also be divisible by 8. Let us take one example, that is 4. Let us take one number, that is 12. 12. Now we see 12 is divided by 4, exactly divisible. The 4, 3 is 12. But 12 is not divisible by 8. Not divisible by 8. We will not get any whole number, right? Therefore, you can say that all numbers which are divisible by 4 must also be divisible by 8 is false. This is false, right? This is false. This is false. This statement is not correct. This is false. Now, G. All numbers which are divisible by 8 must also be divisible by 4. This is correct because 4 is the factor of 8. Therefore, all the numbers which are divisible by 8 must also be divisible by 4. Suppose we have taken one number, that is 32. 32. Now, 32 is divisible by 8. 4 8 is 32. And 32 is also divisible by 4. 32 is also divisible by 4. 4 8 is 32. Right? That means these all numbers which are divisible by 8 must also be divisible by 4 because 4 is a factor of 8. This is true, right? Therefore, this number is true. Now, question number H. If a number exactly divides two numbers separately, it must exactly divide their sum. Let us take one example. Suppose we have taken one number, that is 6 and 18. Now 6 is divisible by 2 and 18 is also divisible by 2, right? It is also divisible, right? 6 is divisible by 2 and 18 is also divisible by 2. If we add the numbers, that is 18 plus 6, 18 plus 6, we are getting 24. and 24 is also divisible by 2, right? That is 2 12 24 equal to 12. Therefore, we can say that if a number exactly divides two numbers separately, it must exactly divide their sum. That is true. This is also true, right? This is true. Next, I. If a number exactly divides the sum of two numbers, it must exactly divide the two numbers. It must exactly divide the two numbers separately. If a number exactly divides the sum of two numbers, it must exactly divide the two numbers separately. Let us take if a number exactly divides the sum of two numbers, it must exactly divide the two numbers separately. Let us take one example. Suppose we have taken the number 36. We have taken one number, that is 36. Now 36 is divisible by 2. That is 2 18 is 36. Right? If we divide 36 as the sum of two numbers, suppose 31 plus 5. Now 31 is not divisible by 2 and 5 is also not divisible by 2. Therefore, if a number exactly divides the sum of two numbers, it must exactly divide the two numbers separately. It is not right, therefore it is false. We can say that this is false. Right? If a number exactly divides the sum of two numbers, it must exactly divide the two numbers separately. This is false. Why? Let us take one example, that is 36. 36 is divisible by 2, that is 18. And if we write 36 as 31 plus 5, then 31 and 5 is not divisible by 2. Therefore, this statement is false. This is the solution of question number 1.